Hi, this is Les and Amy from the RevGenetics podcast. You can listen to the podcast on YouTube and now on Spotify, where we do a deep dive on supplements and longevity studies.
Today, we are unpacking a massive scientific review. It's from 2026, and it completely changes the game for how we might treat one of those difficult diseases out there.
We're talking about triple-negative breast cancer.
We are. And a new technology that acts almost like a microscopic Trojan horse.
It really does sound like a spy movie. We're talking about these things called nanomedicines, which are basically tiny secret agents that sneak into the body to wake up the immune system.
Right.
It's all about taking a tumor that is, I guess, invisible to your body's defenses and just lighting it up like a neon sign so your own immune system can finally see it and attack.
Exactly. It's a shift from just, trying to poison the cancer cells to actually engineering a way to alert the body's own defense systems. It's smart, it's precise, and the science behind it is it's absolutely fascinating.
Okay, let's unpack this. Because when I hear nanomedicines and Trojan horse, I'm picturing a tiny wooden horse rolling through my veins. But before we get to that, we have to talk about the villain here. Why is triple-negative breast cancer TNBC so hard to treat?
That is the perfect place to start. To understand why it's so hard, you have to look at how we usually fight breast cancer. Normally, doctors look for specific handles or flags on the outside of the cancer cell.
Handles, you mean like something the medicine can grab onto?
Exactly. Think of them like little Velcro strips. So common breast cancers have these receptors for estrogen, progesterone, or a protein called HER2.
Okay.
If the cancer has those Velcro strips, we have drugs that act like the other side of the Velcro. They stick right to the cancer and shut it down.
So the standard treatment is kind of like matching a key to a very specific lock.
Precisely. But triple-negative breast cancer is defined by what it doesn't have. It tests negative for estrogen, negative for progesterone, and negative for HER2.
Hence triple negative. So it's like a burglar wearing an invisibility cloak.
That's a great analogy. It really is. Because it doesn't have those flags, those targeted medicines, the smart drugs. They have nothing to grab onto. They just slide right off.
And that's not all, is it?
No, it gets worse. Scientists classify TNBC as a cold tumor.
Cold. Like it needs a jacket.
Not quite.
Yeah.
In this context, cold means the immune system is completely, totally ignoring it. Imagine your immune system is the police force patrolling the streets of your body.
Okay.
Usually, if there's a crime, like a tumor growing, the police rush in. That's what we'd call a hot tumor.
But with this one, the police are just driving by.
Right. The burglar is inside the house, robbing the place blind, but the house looks perfectly normal from the outside. The blinds are drawn, the lawn is mowed. The police, your T cells, they just drive right past because no alarm is going off.
So the burglar's inside, and the cops are outside eating donuts because they don't hear anything.
That's it. So the whole mission of this research we're looking at is, how do we trigger the alarm? How do we force this cold tumor to turn hot so the police finally come rushing in?
And that's where this thing called STING comes in, right? Which I have to say is a fantastic name for a biological pathway.
It is. It stands for stimulator of interferon genes. And you can think of STING as the master fire alarm button.
The big red button.
The big red button, located inside the living room of the cell.
Okay, so it's inside the cell.
Right. And if you can press that STING button, the cell releases all these distress signals. It basically starts screaming, hey, over here, we have a major problem. And suddenly the immune system swarms in.
So, problem solved. Just make a pill that pushes the STING button.
I wish it were that simple.
Yeah.
The problem is the button is deep inside the cell. If you just inject a STING activator into your blood, a couple of bad things happen. First, your body is just full of enzymes that will destroy foreign chemicals.
So the message gets shredded in the mail before it even arrives.
Right. Or, second, and this is more dangerous, if it does survive, it might push the button in healthy cells.
Whoa.
In your heart, your lungs, your liver. And that causes massive inflammation everywhere, which can make a person incredibly sick.
So we need a way to sneak the button presser inside just the tumor cell without setting off alarms in the rest of the neighborhood.
And that is where the nanomedicine comes in. The Trojan horse. This 2026 review highlights how scientists are building these tiny vehicles, nanoparticles, to carry the medicine safely through the blood.
And the disguises are the crazy part, right?
The disguises are incredible. One study they mentioned coated the nanoparticle in a platelet membrane.
Wait, platelets, like the things that help my blood clot when I get a paper cut.
The very same. They literally took the outer skin of a real platelet and just wrapped it around the medicine.
So it's actually wearing a costume.
It is,
Mm.
and it works on two levels. First, to the immune system, it just looks like a friendly little blood cell floating by, nothing to see here. But second, think about what platelets do. They naturally rush to injured areas.
And a tumor is basically a big, messy wound that never heals.
Exactly. So the platelet costume naturally guides the medicine right to the tumor. It sneaks up, gets inside, and then it gets ready to release its cargo.
That is wildly clever. But I also read something in the notes about logic gates. That sounds more like computer programming, not biology.
It is borrowed from computing. It's the concept of AND or OR. So imagine you have a smart bomb locked in a box. You really don't want that box opening up in the heart or the brain.
Definitely not.
So they designed the nanoparticle to only open if certain conditions are met. For example, the environment inside a tumor is usually way more acidic than the rest of the body. It's sour territory.
Okay, so condition one is it acidic here?
Right. But just to be extra safe, they add a second condition. Tumors make specific enzymes. Think of them like little biological scissors that healthy tissue just doesn't make.
Okay.
So the lock on the box says, I will only open if it is acidic AND, if these specific scissors are here.
It's a two-key safety deposit box.
Exactly. If it's just acidic, stays closed. Just enzymes, stays closed. It needs both. That way, it can travel through the whole body safely and only explodes, releasing the medicine when it's dead center inside the tumor.
That is some next-level engineering. And once it opens, it's not just a standard drug, right? I saw them talking about using metals, like heavy metals.
Yes, things like manganese, zinc, even copper. And this is where the biology gets really elegant. These metals aren't just the delivery truck. They're part of the weapon itself.
How so?
When these metals get released inside the cancer cell, they go straight for the mitochondria.
Powerhouse of the cell. I remember that from high school.
You got it. The metals basically damage the power plant, and when the mitochondria break, they start to leak their own DNA out into the main part of the cell.
And I'm guessing DNA is not supposed to be just floating around loose in the living room.
Never. Loose DNA is one of the biggest red flags a cell can see. It usually means there's a virus attacking. So when the cell sees that leaking DNA, it panics.
And it slams the singing button.
It slams that esting button we talked about. The fire alarm goes off, and the tumor instantly turns from cold to hot.
So they're using metal to break the power plant, which causes a leak, which trips the alarm, which calls the police.
That is the perfect summary. You're basically overloading the cell with metal until it crashes and burns in a very loud, very messy way that the immune system simply cannot ignore.
It's amazing how we can use the basic building blocks of nature to do something so sophisticated.
It really is. And, speaking of giving the body the building blocks it needs.
We get to explore the latest in science thanks to RevGenetics.
That's right. RevGenetics has been dedicated to researching evidence-based natural compounds for aging and cellular health for years, always looking at the science first.
And it's interesting, we were just talking about how scientists are weaponizing metals like zinc and manganese to wake up the immune system in these tumors.
It's a fascinating connection. Because while the study uses these high-tech delivery systems to get metals into tumors, we know that just maintaining healthy levels of minerals like zinc or magnesium is essential for your everyday cellular health.
For just keeping your body's systems running smoothly.
Absolutely. It all comes down to having the right materials in the right place.
Exactly. RevGenetics helps you make sure you have those foundational blocks in place.
Okay, so we've got these Trojan horses, we've got smart bombs with logic gates, and we've got metal overloading the power plants. The big question is, what happens next? Does this actually work?
This is the part that gets me really excited. The review looks at the results from animal studies, and they are just staggering. We aren't just seeing tumors stop growing.
No, we're seeing them shrink significantly.
I saw numbers like 90% shrinkage in some of the notes. That's huge.
It is massive. But there's a concept here that's even more exciting than just shrinking the main tumor. It's called the abscopal effect.
Abscopal. Okay, sounds like a telescope. What does that mean?
Think of it like remote control healing. In these experiments, the mice often had tumors in multiple places. So maybe a main tumor in the breast, but also metastasis spread to the lungs.
Which is usually the worst case scenario. I mean, once it spreads, it's very hard to stop.
Right. But here's the magic. The scientists treated only the main tumor with these nanoparticles. They didn't touch the spots in the lungs, left them completely alone.
Okay, so the lung tumor should just keep growing then.
You would think so. But they shrank too.
Wait, how? if the smart bomb only went off in the main tumor, how did the lung tumor know to die?
Because remember, we didn't just poison the cancer cell. We turned on the immune system. We tripped the alarm.
Ah.
Once the police arrived at that main tumor, they inspected the wreckage. They learned what the bad guy looked like.
Oh, I see. It's like giving a bloodhound a scent to track.
Exactly. Once the immune system learned the scent of the cancer at the main site, it went on a manhunt through the entire body. It found the cancer cells hiding in the lungs and took them out, even though the drug was never even injected there.
That is incredible. So you fight the war on one front, and your body wins it on all the others.
That is the holy grail of cancer treatment. You aren't just playing whack-a-mole with every single tumor. You're training the body to find them all on its own.
And there's more, right? The review mentions using other high-tech triggers to make this even more precise, like sound and light.
Yeah, now we're really getting into sci-fi territory. They call it nanobubbles and photothermal therapy.
Nanobubbles.
So imagine injecting these tiny bubbles into the bloodstream. They float around, but they don't do anything yet. Then the doctor uses an ultrasound machine, just sound waves aimed right at the tumor.
And the sound pops the bubbles.
Boom. The sound waves pop the nanobubbles exactly at the tumor site, releasing the medicine. Or they use a laser to heat up particles in just that one spot. It's all about precision.
Hitting the target without hurting the healthy tissue right next door, it's like a sniper instead of a shotgun.
Perfect description. And this technology doesn't just work alone. The review points out that this makes other drugs work so much better. You've heard of checkpoint inhibitors.
Those are the drugs that take the brakes off the immune system, right? You see the commercials for them?
Yes. Drugs like PD-L1 blockers, they're great, but they only work if the immune system is already paying attention to the tumor. Since triple-negative breast cancer is cold.
Those expensive drugs often fail.
Right. But if you use the nanoparticles to turn the tumor hot first.
Then the immune system is already there.
Exactly. You drop the nanoparticles in, they trip the alarm, the police show up, and then you give the checkpoint inhibitor to cut the brakes on the police cars. It's a 1-2 punch.
And the results of that combo?
The data shows it stopped the cancer from spreading and prolonged survival much, much longer than either treatment could alone.
So what does this all mean for a real person, say, 5 years from now? Are we going to see this in hospitals?
That's the hope. This 2026 review really frames this as a roadmap. We're moving from, blunt instruments like chemotherapy, which kills everything that grows fast.
It makes you lose your hair and feel terrible because it's just attacking your whole body.
A precision immunotherapy. We're moving toward a world where we use the body's own defenses, guided by some really smart engineering, to hunt down cancer.
It's not just about killing the tumor. It's about teaching the body how to keep itself safe.
It changes the whole mindset. You're not just poisoning a disease, you're upgrading the patient's own defense system.
And that's a strategy that could apply to so many different types of cancer, not just this one. Once we master this delivery system, the Trojan horses, the logic gates, the possibilities seem endless.
It really feels like we are on the edge of a new era in medicine. It's smart, it's targeted, and it uses the power that we already have inside of us.
And that's the best kind of science, isn't it? The kind that works with nature, even if it uses a little nanoengineering to help it along.
Well, I don't know about you, but I'm going to be thinking about those little nanoparticle bloodhounds all day.
We hope you enjoyed exploring the latest breakthroughs in science with us in today's episode.
Thank you for listening to the RevGenetics podcast.
RevGenetics.com for the best longevity supplements on Earth.